Hello everyone, and welcome to today's webinar in the SERDP and ESTCP webinar series. My name is Rula Adib. I'm a Senior Principal at Geosyntac Consultants in Oakland, California, and the coordinator of the webinar series on behalf of SERDP and ESTCP. I will be facilitating today's call. The webinar will consist of a brief overview of the SERDP and ESTCP programs by Mr. Pedro, followed by a list of upcoming webinars in the series. After Tim's opening remarks, we will transition to the technical portion of the webinar. Today's event features two award-winning ESTCP projects within the Energy and Water program area. First, Mr. Michael West of Adventech Consulting will present an overview of ESTCP-funded research on a technology to save energy and reduce costs through dehumidification and improving air conditioning unit efficiency. Dr. West's presentation will be followed by a brief Q&A session. Following Mike, Ms. Cara Brill of FirstFuel Software will discuss the use of remote audits to improve energy efficiency of a broad portfolio of DoD buildings. Cara's presentation will also be followed by a second Q&A session. Today's broadcast will be listen only. You may submit questions by using the chat box on the left-hand portion of your screen. You do not need to wait until the Q&A period to submit your questions. In fact, we do encourage you to submit questions well in advance of the Q&A sessions. On this slide, we have provided a few suggestions in the event that you experience difficulties with the broadcast audio. Typically, any delay in audio will be fixed if you refresh your screen or call into the conference line. However, if you continue to have problems, please submit a comment using the chat box in the lower left corner of the screen. With that, I would like to introduce Mr. Pedro, who is the ESTCP Program Manager for Energy and Water. Before joining ESTCP, Tim worked at the National Renewable Energy Lab, where he focused on energy efficiency and renewable energy project development for the federal sector. Tim?
Thank you, Rula, and welcome everybody to today's SERDP and ESTCP webinar. SERDP is the Strategic Environmental Research and Development Program. It was established in 1991 by Congress as a partnership between the DoD, the Department of Energy, and the EPA. SERDP's mission is to identify and address high-priority environmental science and technology opportunities that focus on DoD requirements. SERDP funds both fundamental research as well as advanced technology development that ultimately impacts real-world environmental management. ESTCP is the Environmental Security Technology Certification Program in which we demonstrate innovative environmental and energy technologies. These investments capitalize on past investments under SERDP or other research programs and are designed to transition technologies out of the lab and into the field. Especially important in all ESTCP demonstrations is the ultimate transition to implementation and regulatory acceptance. SERDP and ESTCP are complementary programs, with much of SERDP research occurring in the lab and pilot scale with occasional field efforts, while ESTCP demonstrations are primarily at the pilot and field scale, although occasionally supported by lab efforts are conducted. Slide 11. There are 4 program areas in SERDP and 5 in ESTCP. The Energy and Water program area is only in ESTCP, while the other 4, environmental restoration, munitions response, resource conservation and resiliency, and weapon systems and platforms, are both SERDP and ESTCP programs managed jointly by a designated program manager. Our webinar today is focused on research and demonstrations that were conducted under the Energy and Water program area. Energy and Water has essentially 3 main areas of research. The first is smart and secure installation energy management. second, efficient integrated buildings and components, and third, distributed generation. Our webinar series will be highlighting research and demonstration efforts from each of the 5 program areas, and we have launched a new mini-series in 2017, beginning with today's webinar to highlight research findings from CERDP and ESTCP award-winning projects. As you can see, our webinars will cover a broad range of topics, including monitoring and assessment of environmental risks posed by munitions constituents in aquatic systems, and 4 dioxane cleanup technologies at DoD contaminated sites. And our next energy and water webinar will be following the dioxane impacts webinar and will be on April 20th. You can find more information about upcoming webinars at this link, and registration is now live for several upcoming events. And I hope you enjoyed today's webinar. Rula?
Thank you, Tim. It is now my pleasure to introduce Dr. Michael West, who is the CEO and founder of Adventech Consulting. Dr. West has over 20 years of experience with HVAC performance and design, energy efficiency measurement and verification, and central energy plant optimization. As a faculty member at the University of Florida, Mike focused his research and development on advanced energy technology. He also designed thermal environmental systems for U.S. Navy submarines. He is the author of many articles for practicing HVAC designers and hands-on facility managers. Mike received a doctorate in thermal science from the University of Florida, is a licensed professional engineer, and holds EPA 608 Types 1, 2, and 3 refrigerant certifications. And with that, I turn it over to you, Mike.
Thanks, Rula. Hello, everyone. What I'm going to go over today is the first background of DX air conditioners. Then I'm going to explain the technology, talk about 3 demonstrations at 3 different sites, and then show you some of the results from those demonstrations. And then I would talk about application of the technology to real projects, and then finally conclusions. DX air conditioners are everywhere. They include rooftop units, package units on the ground, split systems, and portable units. They're usually small and out of the way, and they often go unnoticed, but they are everywhere. Actually, 60% of U.S. commercial space is cooled with rooftop package units, and over half of building cooling energy consumption is from DX package equipment. Annually, over 300,000 new units are installed, and there are about 1.6 million legacy units operating at pretty low efficiency levels. For DoD, there are about 100,000 of these units spread across 20,000 buildings. There are 4 energy efficiency rating definitions that I just want to go over. These describe how energy efficient an air conditioner is. The first one is the energy efficiency ratio. That's the EER, and that's just at a single point. It's the efficiency at full load at 95 degrees outdoor temperature. The second one is the IEER, or integrated energy efficiency ratio. This is a weighted average of efficiency at 4 different temperatures and 4 different loads, and gives a more real-world description of what the air conditioner's efficiency will be in actual operation. Those first 2 are usually the main ones you see with commercial equipment. The next 2 I just put here for the sake of completeness. The seasonal SEER is usually for smaller equipment, 5 tons and under, usually residential or small equipment. And the IPLV is an older rating that you might see, but it's no longer used. It's similar to the IEER. The drivers behind increasing energy efficiency, the minimum IER ratings that manufacturers are required to meet are pretty modest, really, as compared with the state-of-the-art. Even the 2023 minimum of 13.2 IER is well below current state-of-the-art. More ambitious drivers are Energy Standard ASHRAE standard 90 and ASHRAE green standard 189, and also LEED version 4, which has been out about a year. These are all pushing manufacturers and engineers to use and specify more efficient equipment. Another driver of improved DX technology is dehumidification needs. Dehumidification has become much more important over the past several years. There's really, say, 2 or 3 reasons for this. One is that reduced sensible loads means a lower SHR, sensible heat ratio. What's happening is as buildings are becoming more efficient and lighting is becoming more efficient and glass is more energy efficient, those technology improvements are addressing the sensible or the dry heat load. SHR is the ratio of the dry heat load to the total heat load, or the total amount of cooling that air conditioner has to provide. Is really a split between sensible, which is temperature-related cooling, and dehumidification, which is latent cooling. So what's happening is that ratio has shifted over the past several years to where now dehumidification is becoming a bigger part of the cooling load. It's becoming more important. And what we're seeing in the field is that since these packaged DX air conditioners really come with maybe a 70-30 or a 75-25 split, where 70% of the capacity is for cooling and 25% or 30% is for dehumidification, they're not able to meet the humidity loads, and we see a lot of reheat being used. And reheat's very energy intensive. We're also seeing standards that are having effect to actually specify how much dehumidification is required. So the ClimateStack technology addresses both these things, both the energy efficiency and the dehumidification needs. Just to get us all on the same technical footing, and just to better understand how ClimateStack technology works, let's take a minute just to review the basic DX air conditioner inner workings. So these are the 4 main components of a DX air conditioner. We can start with the compressor at the bottom. The compressor compresses the refrigerant vapor that comes from the evaporator coil, which is, let's say, mostly vapor, and it compresses it to a high pressure, high temperature gas, which will be the red line, where it goes to the condenser coil, and in the condenser coil, outdoor air flows through the coil and removes the heat as the refrigerant condenses from a high pressure gas to a high pressure liquid. From the condenser coil, the liquid goes to the thermostatic expansion valve. And this is really where the magic of refrigeration happens, is where the liquid, which is high temperature, in a standard system it may be, say, 10 degrees above ambient. So if it's 90 out, it's probably around 100 degrees. And it is expanded to a low pressure mixture of vapor and liquid that's maybe at about 45 degrees. So that mixture of vapor and liquid then goes to the evaporator coil, and the liquid that remains evaporates, and in the process cools the conditioned air, and then the cycle repeats. This is the same very basic cycle that Willis Carrier patented back in the 1920s, and it's very much or exactly like what you'll find in most DX equipment today. There are some subtle but important limitations that ClimateStack was designed to address of this cycle. The first one being in the expansion valve, where the pressure and temperature is reduced. Here, a significant amount of the liquid flashes the vapor, and that's an important limitation, because if you go to the evaporator coil, how the evaporator coil cools the air is by evaporating the refrigerant, and as the liquid turns into vapor, that's what cools the air. So if we have vapor leaving the expansion valve, that vapor going to the evaporator coil, the liquid that has flashed to vapor, doesn't do much significant cooling. It's pretty much not very useful. The other limitation that ClimateStat addresses is at the condenser coil when the high pressure gas is condensed, and it is then subcooled, but it can only get within about 5 or 10 degrees of ambient. So if it's 95 outside, you can't really cool that refrigerant to much below, say, 100 or 105 in best case. And then when you're trying to achieve 45 degrees, you've got a long way to go. So ClimateStat modifies the cycle by adding an additional component, which is right here. This is the liquid suction heat exchanger separator device. It has no moving parts. It's simply a heat exchanger container. And essentially what it does is subcool the refrigerant or make it colder before it reaches the TXV. So instead of it being 100 degrees of liquid refrigerant, it would be, say, 75 degrees. And that means there's more liquid going into the evaporator, and it improves the refrigerant two-phase heat transfer in the evaporator coil. The second thing it does is it separates out the liquid and vapor so that we can have liquid all through the evaporator coil and not have to waste any of the heat transfer surface area superheating the refrigerant. And the end result is that the refrigerant that reaches the compressor is colder and has a higher density, so we get improved compressor volumetric efficiency. And finally, taking advantage of these things, we can make adjustments and control on the air side of the air conditioner to improve performance. This is done really one of two ways. The most elegant one is the optimizing control package that goes with the technology. This one optimizes the operating parameters and takes best advantage of what the ClimateStat refrigeration side is able to offer. It continuously tunes all of the operating parameters of the air conditioning with the target being the maximum energy efficiency ratio. It has features like web monitoring, fault detection and diagnostics. This would be optional instead of the standard PID temperature control that's used with ClimateStat. So a ClimateStat equipped air conditioner has these changes that are made to it. These components that are added or changed from a basic air conditioner. We have the optimizing control pack or a standard PID temperature controller. We add the liquid suction heat exchanger separator device into the refrigerant circuit. We add a bypass damper to the evaporator coil. If the unit doesn't already have an expansion valve or an adjustable expansion valve, we either change the expansion valve or add an adjustable thermostatic expansion valve. And then finally we use either a variable speed ECM blower motor or put a variable frequency drive on the blower motor. And that's essentially what transforms a basic package air conditioner into a ClimateStat equipped air conditioner. The technology was demonstrated at 3 field sites over a full cooling season. The 3 sites differ in equipment type and climate, giving a very broad window of application. The first demonstration was at Marine Corps Air Station Beaufort in South Carolina. This is a temperate climate. The equipment was an old legacy air conditioner with the old R22 refrigerant and in very bad condition. So this was one endpoint of the demonstration. The second one was at Naval Ordnance Test Unit in Cape Canaveral, Florida. This is a hot, humid climate. The equipment here was new, brand new, installed in 2012, and it uses R410A. This one is electric heat, and the one in South Carolina, I forgot to mention, was natural gas heat. And the third site is in the desert at Fort Irwin National Training Center. This was our R410A package unit. It's a heat pump for heating, and the climate here represents the opposite extreme from the hot, humid Florida climate. The units were comprehensively instrumented. It was extremely rigorous according to ESTP's requirements. The results, we did extensive propagation of error analysis. The end result of the energy efficiency measurements was accurate to 0.6 IEER points, or about 5% accuracy. 45 sensors on each one of the air conditioners. Pretty much the easiest way to describe that list of sensors is anything and everything was measured, all pressures and temperatures, airflows, humidities, and so forth. Data was collected for 2 full cooling seasons. The first cooling season was without the technology as a baseline, and the second cooling season was with the technology, and then the results were rigorously analyzed. Some key findings from Site 1. The climate-stat efficiency, which would be the second summer versus the first summer, improved from 11.2 to 13.4. The unit varied its dehumidification capacity to match the space load, meaning in more humid conditions it would provide more dehumidification and keep the humidity below 60%. And during drier times of the year, it reduced the dehumidification capacity, allowing the humidity to float upwards into the 50% area and improving the energy efficiency, or reducing the amount of energy consumption of the unit. At Site 2, the efficiency with the climate-stat improved from 12.5 to 15.9, so 27% improvement. Key here is that reheat was only used at 0.5% of the cooling hours, and this was maintaining a 45% space relative humidity level. This was a laboratory environment that had a very tight requirement for temperature and humidity, and the existing previous unit used a lot of reheat to maintain this level of humidity, whereas the climate-stat unit used very little reheat. And the efficiency rating here at 27.2% does not count the reheat savings. It'd be much, much higher if we counted that. This is just looking at the cooling efficiency. Site 3, we're still analyzing data. Preliminary results show 24 or 26% improvement at that site. Key here is what we are comparing our efficiency against, or versus what. So we can look at improvement over factory rating, or we can look at improvement over the actual operating efficiency. And typically the field efficiency of the unit installed in the actual climate we found was a little bit less, or significantly less, than the factory rating. So that's why we gave 2 different percentages here, versus factory rating and versus what the actual efficiency was. To summarize from the Naval Ordnance Test Unit in California, we had 10% fewer compressor runtime, 27% higher efficiency, 39% more dehumidification, and 15% less electricity. So at the South Carolina site, the efficiency went from a 9.5 to a 13.4, giving a payback period of 4 years for that site. At Cape Canaveral Air Force Station, NO2 in Florida, it went from a 12.5 IEER to a 15.9. Dehumidification capabilities increased significantly, and the payback was 2.6 years. For DoD facilities in general, the field retrofits are suitable for large RTUs with at least 5 years of service life left. Factory installations are cost justified for almost all new RTUs, and potential total of $110 million savings across all DoD facilities. As for application, the study shows that climate-stat is 36% more cost-effective as a way of achieving higher energy efficiency. Comparing 3 units here, we have the flagship model versus a midline model versus a base model with climate-stat installed, and a base model, a climate-stat equipped base model. So if we look at a flagship model, which is maybe kind of like the Ferrari or the Corvette of air conditioners here, has a very high IEER, but the cost is also very high. And if we look at the ratio of the cost per amount of efficiency points you're getting, it's about $1,387 per EER point. If we look at a typical midline model with an IER of 11.4, the cost per IER is less, but also our IER efficiency is pretty low at 11.4. So the ClimateStat offers a solution where we can get a moderately high IER of 15.9 at a much lower cost per IER point. And really with these units, it's not about being the Corvette of air conditioners. It's all about economics and reliability. Application example, the current cost for installation of ClimateStat on a new 20-ton unit would be a little under $5,000. The benefits for specific climates, of course, it changes depending on climate. Let's say is $1,900 per year. This would be for a temperate climate and improved dehumidification. Payback period, 2.6 years. Maintenance needs are not increased. The Utilities Director, Energy Manager at Marine Corps Air Station Beaufort was very happy with the installation there. He said that they're happy with the performance of the unit due to the fact that he had no complaints. In the maintenance world, no complaints is considered a job well done. The unit performed. It's actually still operating 4 years later, and it still has no problems. Selection of which units to apply to. The best applications, the ones that you really want to look for, are RTUs with some sort of active dehumidification, or a humidistat is a good way to tell if it has active dehumidification. Better is large DX units, 25 to 60 tons and larger, and good is mid-size RTUs from 10 to 25 tons. Really, the way to tell whether it's whether these gray area RTUs are economically justified is to perform an RTU-CC. It's a rooftop unit comparison calculator. It's an online software tool from Pacific Northwest National Lab, economic analysis, and we can do that. Typically, we find that it's not cost effective for units that are smaller than 10 tons unless there is a strong dehumidification need. And for existing units, you want to have at least 5 years of remaining service life. The unit needs to be in good condition and still with the original compressors, not had a compressor replacement. Procurement, we found, can be a little bit of a challenge. For new equipment, two ways of doing it are either guide specifications for the bid to include the ClimateStat technology or a description of the technology in the specs. It would need to be a generic description. Another way is a sole source justification. I'm given a link here to the DCCH FAR subpart 3 just as a reference to see exactly how that's done. Either way, the new RTU package unit would ship from the factory to Climatech HVAC LLC for installation, and then from there ship to the project site. Existing equipment usually starts with an economic analysis of different RTUs that look like they'll be good candidates to calculate the savings to investment ratio and the payback period and select which ones it's justified for. And then it's implemented with a contract task order to Climatech for retrofit of the existing units on site and training of the local service technicians. In conclusion, the demonstration showed that ClimateStat improves the energy efficiency and the dehumidification performance of DX air conditioners. We saw on average 21% reduction in energy costs, doubling of dehumidification capacity, and improved air quality through lower humidity. Cost effective with payback from 3 to 5 years. The IER ratings improved from 17 to 46%, depending on whether you're looking at the factory rating or the actual installed efficiency for the retrofitted units. Comfort and reliability was equal or improved, and there were no additional maintenance concerns. There's a link here. At that link, you'll find the final report and cost and performance report for lots more detailed information. And of course, please feel free to email me or call me with any questions that you have. I'll be glad to do my best to answer. And I think, Rula, I'll turn it back to you for questions.
Yes, thank you, Dr. West. I would like to remind our audience to submit questions by using the chat box on the left-hand portion of the screen. We have received a number of questions on the first presentation that Mike will now answer. So the first question, Mike, can you please tell us under what outside temperature conditions does the technology have the greatest impact? Is it best during moderate outside temperatures?
Yeah, from the results of the testing, it seems like the sort of in the average temperature range, say between 82 and 95, if I had to put numbers on it, would be where it has the most effect in the mid-temperature range and the shoulder seasons. It does improve performance at the peak highest temperature, but not as much as in the mid. And what's important to note is that usually those highest temperatures are only a few hours a year, probably less than 100, whereas the mid-temperature range is where the air conditioner is going to operate for 2,000 or 3,000 hours per year. So that's really where you got your energy efficiency savings.
Thank you. A second question for you. What specifically is done to an air conditioner unit when it's being fitted with Climastat? Can you elaborate on that, please?
I sure can. Can I go back to a specific slide there? See if I can do that.
Sure.
Is that okay to do that, Rula?
Which slide, and I'll take you back.
Okay, I think it's this one.
Just double click
there we
on
go.
it. Perfect.
Oh, well, yeah, actually, you know what? It'd be better to do this one. Okay. These are the 5 things that we either add or change. We either add an optimizing control pack, which optimizes all of the components, operation of the fans, blowers, and compressor, or we can use a standard PID temperature controller, which is lower cost. Depends on the application and the economics. We add a liquid suction heat exchanger separator. This is a heat exchanger that has no moving parts. We add a bypass damper, and the damper also has an actuator. We add a adjustable thermostatic expansion valve. In some cases, units already come with adjustable expansion thermostatic TXVs, whatever, and we can use what they have, or sometimes we need to change or add. And then the blower motor, we either change it to an ECM motor or we add a variable frequency drive to the existing motor.
Perfect. Thank you so much. Another question. What happens with a unit's warranty when you fit a brand new unit with Climastat?
Well, that's a great question. I guess technically what happens is it voids the warranty because we break into the refrigeration circuit. We do take over the warranty. Warranty on these units is usually a year. We haven't seen any additional problems. In practical matters, what actually happens is the manufacturer will cover the warranty for the non-refrigeration circuit components. For example, typically the types of things you see that go bad in the first year or two might be a bad fan motor or a bad contactor or a relay, and usually the local service people will cover those under warranty. Otherwise, we assume the warranty for if it's a new one for the full warranty period, or if it's an existing unit that still has warranty for whatever portion of the warranty is remaining.
Great, thank you. Is the optional control pack necessary to get the energy savings that you discussed?
No, it's not. The optimizing control pack will give additional savings because it does a lot of other things. But to get the savings that we're talking about here in this presentation, strictly from the Climastat, it's not needed. It's just an option to offer some additional features. So we could use just a standard PID temperature controller.
Thank you. In a multi-compressor DX unit, does Climastat use 2 independent systems, or are the 2 systems combined and 1 heat exchanger added?
They're kept separate. We think it's really important to have 2 separate isolated systems for redundancy, or in case one compressor fails, it doesn't contaminate the other compressor. So these are completely separate, whether it's 2 or 4 compressors. However many separate refrigeration circuits there are is how many liquid suction heat exchanger separators that we add to it.
Thank you. Can you tell us how much of the efficiency gain from the climostat retrofit comes from adding the liquid suction heat exchanger separator?
It's really difficult to divide that out because it works as a integrated system. The refrigeration, the liquid suction heat exchanger separator by itself creates energy efficiency improvements and save energy, but it also allows changes in the way the system operates, which you wouldn't ordinarily be able to do, which those also produce energy savings. One way to tell might be to look at these numbers between the energy efficiency increase versus the energy consumption savings. And the differences in those two might give some indication of how much of the percent savings would be due to just that one component versus the whole system. But again, it's really hard to break it out.
Thank you. Can you tell us why manufacturers like Carrier or Trane aren't putting this in their units?
The large manufacturers are just very big companies that have long product development times and extensive testing regimens that take years to implement new technologies. There is definitely interest from manufacturers in this, but it's at the very, very beginning stages of their implementation cycle. They usually have to wait till a new product development comes along.
Thank you. Two more questions, maybe three, and then we'll shift to our next presentation. Can you tell us, please, if all the baseline RTUs in the study involved constant speed fans?
Yes, they all had constant speed fans. The baseline units did, yes.
Is the optional control pack, let's skip this question actually, my apologies. Does climostat hurt the longevity of the compressor?
Well, if anything, although we didn't run the demonstration long enough, I think these units are going on 4 years, I believe, or maybe 3 years, to really be able to tell, because compressors supposedly last 5, 10, 15 years. But what I can tell you is that there weren't any compressor failures due to our system, and we can say that the liquid suction heat exchanger separator has two functions that actually protect a compressor from any kind of failure. One is all of the liquid is separated out at that point, so liquid can't reach the compressor, and liquid in the compressor, of course, liquid doesn't compress and it can damage the compressor. The other thing is we measured compressor discharge temperatures and compressor case temperatures that were about 30 degrees cooler. So the compressor is running significantly cooler than it does without climostat. And we think those two things are going to actually increase compressor longevity, but we don't have long enough or enough data to really be able to say for sure yet.
Thank you. Can you tell us if this technology is cost effective when you're only using it in one unit, or would this be mostly cost effective for larger scale applications?
That's going to depend on whether it's a field retrofit or a installation on a new unit. If it's a new unit, definitely one piece of equipment will certainly have good economics. If it is a field retrofit, it really needs to be a larger unit to generate enough savings to cover all of the field costs of doing work like this in the field is pretty expensive and it's very intense. So typically if it's going to be a unit, say it's over 30, 40, 50 tons or 60 tons, one unit can justify it. But if it's going to be smaller units, say 25 or 15 tons, it would probably need to be a few units.
Thank you, Mike, for entertaining all these questions. at this point, we're going to transition to our next speaker, who is Ms. Cara Brill. I'm going to take us back to Cara's presentation here as I introduce her. Cara is a manager at FirstFuel Software. Since 2012, she has led many projects for utilities and government, including General Services Administration, Efficiency Main, and the Rapid Building Assessment for DoD. Cara works closely with FirstFuel's engineering delivery team to engage building operators and owners. Prior to joining FirstFuel, Cara managed regulatory and project development for the clean tech startup ZGen. She successfully secured initial regulatory approval for ZGen's first commercial gasification facility. Cara graduated Phi Beta Kappa from the University of Richmond with a double major in history and rhetoric and communication studies. And with that, I turn it over to you, Cara.
Thank you, Rula. So today I'm going to talk with you all about how data can help you achieve your energy savings goals. First, I'll give a little background on FirstFuel software, what exactly analytics-enabled energy efficiency means. Then I'll talk about the details of our ESTCP project with the DoD, including our findings and outcomes. And I'll also talk about our work at one of our sites, Fort Bliss specifically, and then go into our ESTC project, lessons learned, and overall conclusions. So what is FirstFuel? We are an energy intelligence company. We combine data science, building science, and enterprise software as a service to make up a unique energy analytics platform. To dive a little deeper here, what happens is our data analytics team pairs their extensive modeling knowledge with our experienced building energy engineers. They have backgrounds in walking buildings and conducting energy audits. And then our software team combines that unique expertise in an online portal that presents easy to follow energy information and energy actions for our customers' buildings. Our customers are utilities and large building portfolio owners like the General Services Administration, and we're currently deployed at more than 30 customers. Our platform addresses the life cycle of energy efficiency. By life cycle, what I mean is that as we work across the energy efficiency spectrum, we start by working with our customers that have a large portfolio of buildings, taking the building's energy data, and then screening them for potential to save energy. Once those high potential buildings, so those buildings with a high potential to save energy are identified, we take those buildings and conduct remote energy audits using our online tool, present the findings back to the building owners, and encourage them to implement those building-specific energy savings opportunities that we identified. And then once those projects have been completed, FirstFuel can remotely monitor the building's energy performance, which allows the building owner to track those savings in a weather-normalized fashion. And what I mean when I say weather-normalized is that we're able to look at how the building is performing compared to that baseline audit period, which is the 12 months of data that we're looking at in the building during that remote audit, and we take out weather from the equation. So that remote audit tool that I just referred to in the life cycle of energy efficiency was the focus of our ESTCP demonstration. Our audit solution allows us to take minimal data inputs from our customer. We just need the building's address, 12 months worth of interval electricity data, and a brief building information survey completed by the site manager. We then combine that information with detailed weather data and GIS data to perform an analysis of how the building responds to changes in occupancy and weather, and then we're able to use that to come up with a breakdown of how the building is using energy down to its 7 major energy end uses. That allows us to see where there are opportunities for savings. And since we're using building-specific data, our recommendations are also building-specific. So we're able to see things like uncontrolled heating and capital inefficiencies like older vintage lighting. We always present the findings of each audit back to the customer via webinar. This helps us to verify our findings as well as to talk through the next steps of where the building owner can implement these savings opportunities based on what was discovered through the data. Okay, so now on to the specifics of our ESGCP demonstration. FirstFuel started our project in the fall of 2011. Our demonstration was aimed at helping the DoD overcome its challenge of identifying savings opportunities across its vast and diverse portfolio of buildings. We specifically were aiming to address this problem by conducting remote energy audits on 100 DoD buildings, using those buildings' interval electricity data, and then comparing our results to on-site audits of a subset of those buildings. In addition to looking at this remote audit versus on-site audit comparison, we also set up a demonstration to focus on being able to analyze 5 different building types that are unique to the DoD and listed out here on this slide. And we also were wanted to make sure that all of the sites we worked with were scattered throughout the U.S., so we were able to capture a variety of U.S. climate zones. We ended up working with 11 different sites using their advanced metering data, building energy surveys that the site managers completed, and then we took that information and ran it through our platform and presented the results back to the energy site managers at these different installations. We worked closely with ESGCP to define the performance objectives of the demonstration, just like we work with all of our customers to define the right criteria for measuring success right from the beginning. With this demonstration, we focused on 3 main objectives: cost, scalability, and accuracy. And I'll talk about the details of these in a few slides. Here's an overview of the specifics of our workflow of our remote audit process during the ESGCP demonstration. So once we collected the necessary data, the 1 year worth of interval consumption, where the building was located, and once the energy site manager sent us the questionnaire, we combined it with weather data and GIS information, ran it through our platform. FirstFuel building energy engineer reviewed the results, and then we presented those results to the site. If there were updates that were needed, the energy engineer would then immediately update the building on the portal, and the energy site manager had access to the portal so he could see the updates that were made pretty instantly, check out all the recommendations, and download the PDF report if necessary. If the site manager ended up implementing any of the projects, then they could also track the building's performance via the monitoring section of the tool. That's assuming that they continue to send us data. And as I mentioned earlier, part of this demonstration was focused on comparing our results to on-site audits. While we were conducting these 100 remote audits, we had that third-party engineering firm during the on-site audits on a subset of buildings. And from this, we learned 2 big benefits. One of them was that we realized that the remote audit approach can not only be performed more quickly, but we can be doing a number of buildings concurrently, which means that we can perform remote audits or give the site manager audits on, let's say, 50 of their 100 buildings pretty quickly, whereas an on-site team has to take a full day to walk each building and then go back and prepare the paper reports. We also realized the benefit of reducing the hassle for the energy site manager, since they didn't have to chaperone anyone while we analyzed their buildings. Here's an example of the results of our demonstration using one of the charts that we have in our portfolio tool. Each bubble here represents one of the 100 buildings analyzed. The size of the bubble represents the annual kWh savings. So the bigger the bubble, the more kWh savings potential were identified in the building. Overall, we were able to identify 14 million kWh of savings, which equals just over $1 million in savings annually if each of the projects were implemented. Another benefit of being able to analyze a number of buildings concurrently is that you're able to plan which buildings to target for savings at the portfolio level. Instead of having to extract the information out of each audit report and come up with an Excel-based plan, our tool has the ability to allow portfolio managers to identify and rank which buildings to go after first. So here's an example of some of the charts that we did for our ESTCP final report, where we're looking at the total savings that were identified by building type across the 100 building portfolio. And what you can take away from here is that if you're a portfolio manager looking at these 100 buildings and want to figure out where you can get the most kWh per square foot, you would want to look at type 4 buildings first, which are rec centers or gym facilities, and then probably move on to type 1 buildings, which are administrative buildings and headquarter buildings. Now that you have a sense of the portfolio level findings, I'm going to dig a little deeper into one of the sites that we specifically worked with, which is Fort Bliss. Fort Bliss was a great partner site for us for a number of reasons. First is that they have very aggressive net zero energy, water, and waste goals by 2020. So piloting our remote energy audit tool was a way for them to identify concrete opportunities to meet those energy goals. They also have a very wide range of building types, which helped us meet our building type goal, and they have a mix of very old and very new buildings with advanced meters on a lot of the old and new buildings. And so one of the things that we found that wasn't too common at the start of our demonstration was that those advanced meters were not deployed on a number of DoD sites that we were trying to work with for more than a year. And our audit tool requires 12 months worth of data, so that was a really good benefit for us working with Fort Bliss. And then finally, a huge challenge that we encountered while we were working with the DoD that we hadn't seen before was that some of their buildings are not occupied for all months of the year due to deployments and different building purposes, which was something that we hadn't seen before and was an important research item for us as we went through this demonstration. Here's an example of the results of a remote audit at a physical fitness center at Fort Bliss, where we were able to identify 24% electricity savings. One of the advantages of our process is that we're able to look at how a building consumes energy over that 1-year period, which means we can identify opportunities that are often missed by on-site auditors that are looking at the building at a 1 or 2 day period when they're walking through it. In this building, the top savings measure is HVAC scheduling control, which is a low-cost savings opportunity here that represented a payback of 3 to 6 months. And it's hard to see, but the table is a picture of our recommendations page on the portal that each building's analysis gets. And it's on this page in the portal that we provide a detailed description of the energy savings measure. So if you click on the energy saving title, you'll get a drop down of the reasons that we included the measure, what the data was that was driving us to that measure, and then we also include the energy and dollar savings as well as the range in cost and payback. Next, we have an example of the recommendations that we identified at a vehicle maintenance shop at Fort Bliss, where we were also able to identify significant operational savings. This building type, the vehicle maintenance type, was new to us at the time, but we found it was a very common building type across all of the DoD sites that we worked with. While we present these savings to each of the site managers, on the webinar, we always review and discuss the data and analysis that's driving us to the conclusions of these savings opportunities. And here we spent a lot of time going over the evidence that pointed us to suspected simultaneous heating and cooling, as well as HVAC operating and scheduling issues that we identified in the building, because we knew that this would be a quick and low-cost savings opportunity for the site manager to take advantage of at Fort Bliss. When we started working with Fort Bliss, like most other sites that we started working with, in the beginning, the energy site manager had a healthy level of skepticism about what analytics-enabled energy audits could offer. And they ended up finding the process valuable for identifying energy and cost savings across all the buildings we looked at. The site manager was able to find the recommendations actionable enough to put a number of them in his 2015-2016 project planning for achieving those net zero goals. And another benefit we found here that was unexpected at the beginning of our demonstration was that we were able to provide significant value to their previously untouched data stream of energy data from their advanced meter deployment. So before we started working with them, the data was sitting on their servers unused, and when they extracted it for the purposes of these audits, they immediately found opportunities to improve their data collection and storage process. As I mentioned earlier, ESTCP and FirstFuel worked closely at the beginning of our project to design performance objectives. We settled on three major ones, which were cost, scalability, and accuracy. On cost, we were aiming to perform the audits at an average cost of $3,000 per building, and we were able to achieve that. On scalability, we were aiming to complete the audits in a certain time frame compared to the on-site audits that were happening on those subset of buildings. And we were really pleased that we could complete the audits in 15 to 16% of the time compared with the traditional approach. Third, on accuracy, we established three criteria for success here. Two we met very clearly, and one we fell a little shy on. That one was our ability to match the recommendations of the on-site audits in the administrative buildings. However, we were able to find a number of recommendations that were not identified by the on-site audits in those buildings. And we did hit our goals for finding measures similar to the on-site audits in the other building types. Overall, we learned some very valuable lessons about the process and how we can assist the DoD and other large portfolio owners in meeting their energy audit and energy efficiency goals. The high-level goal of our ESTCP project was to prove the technical value of FirstFuel's remote audit tool, and we consider the project successful because we met that objective. And we're proud that we were selected from 65 energy and water projects as Project of the Year. One of the big lessons we learned and that I alluded to with Fort Bliss was that the challenge around meter data management at DoD sites, collecting data and making sure that the data was accurate, was a big hurdle to getting the remote audits done, completed, and presented back to the site managers in an accurate fashion. So to go into a little bit more detail here is that when we started working with the sites that did have advanced meters deployed for more than a year, a lot of them were not using the data in a meaningful way, which meant that data collection and data storage issues weren't discovered until they pulled the data and sent it to us for the audit. I think that this issue has come a long way since 2011 and 2012, but we did learn that there was an opportunity to increase the value of the DoD's AMI rollout here. Second, we learned a lot about how the tool can be used to analyze a wide variety of building types. Before we started this project, we were just looking at offices and schools, and we were able to expand our repertoire into more DoD unique types. And then finally, we learned about our ability to provide portfolio level insights for better targeting and planning, which is a significant advantage of our tool over on-site audits. Now that our remote audit approach has been validated, when we work with sites, we're shifting our focus during the webinars to reviewing the opportunities that we identified and emphasizing the need to focus on measure implementation. In conclusion, we continue to work with the DoD and other customers to prove that analytics-enabled energy efficiency provides valuable and actionable information for parties that are interested in portfolio level and building level information. Using analytics provides a quicker and cheaper solution compared to on-site audits, while also identifying low-cost operational savings opportunities that help buildings achieve aggressive savings goals faster. Thank you, everyone, for your time, and I look forward to your questions. I really appreciate the opportunity to discuss our project with you.
Wonderful. Thank you so much, Cara. If folks are interested in submitting additional questions, please make sure to use the chat box in the left corner of the screen. We've received a number of questions for you, Cara. So starting with, what are the criteria for optimizing the success of an FF program?
So we use a variety of building types in our audit tool now. Before we started working with the DoD, we were mostly just working with schools and offices, and so those were where we would have the most success with completing remote audits. But now that it's been quite a few years and we've done a lot of work with the DoD on additional building types, we have really no best case scenario. We're good in almost all climate types, all different commercial building types. The biggest and consistent criteria, though, is that we still need 12 months worth of interval electricity data.
Thank you. Another question for you. Could the building's analytics approach be applied to other building improvements, such as indoor air quality?
If there were data on indoor air quality, probably. But what our tool is doing is looking at the 15-minute or 30 or 60-minute interval, kWh intervals of the building over the 12-month period, and how that energy change, how the occupancy and weather changes impact those intervals. So I'm not sure that air quality would necessarily fit into that analytics spectrum.
Thank you. Can you give some examples of ECMs that were found in the on-site audit but not found by the FirstFuel remote audit?
Off the top of my head, I don't remember many examples. I think there was one where there was an out-of-date piece of equipment that they recommended being replaced that wasn't used much during our assessment period, so we didn't pick up on that. But that's the only one I can remember.
Thank you. Is the energy audit tool a service that FirstFuel offers, and does it have benefits over other energy audit tools such as Energy Star or ASHREA's Building EQ?
Yes, so the GSA currently uses our remote audit tool to meet its ISO 432 requirements. So we are taking the GSA's building energy data and remotely auditing their buildings and helping them meet their federal audit guidelines. Our advantages over the tools that you just mentioned are that we're not using any building simulations. We're looking at how the building performs using the building's data specifically.
Thank you. Two questions on slide 46, and I'm going to pull that up for you. Can you tell us where whether energy analytics reviewed for industrial, were the energy analytics reviewed for industrial type buildings? That's the first question, Cara.
No, they were not. So FirstFuel's process does best when there is a pattern that relates to changes in occupancy or changes in weather. And industrial processes are typically driven by whatever's going on in that industrial process, right? So we are less able to pick up on areas for improving building energy performance using our tool if there is something going on in the building that's not related to weather or occupancy. And that's usually such a large portion of the building that's what happens.
Thank you. Another question on the slide. Is building level meter data required for the analysis shown here?
Yes. So we have to have 12 months worth of interval electricity data for each building, and that's what was used at each of the 100 buildings across the 11 sites.
Great, thank you. Do the audits meet the EISA 432 requirement, which is that federal buildings over a certain size have to be audited every 4 years?
Yes, and that's what we've been doing with the GSA since 2012, auditing a number of their buildings to help them meet those federal auditing requirements.
Great. Can you tell us how much of the potential savings that you calculated are actually realized in practice, given that this project has been finalized for a few years now?
No, I actually don't have much follow-up data there, but that would be a good next project.
Thank you. Does your solution address energy opportunities beyond energy efficiency?
Yes, so our solution is now looking at opportunities with reducing peak demand. We're also doing water audits with the GSA and looking at opportunities for solar installations with some of the DoD sites that we've been working with since this project.
Thank you. All right, one last question for you before we pull Mike back in. What are the requirements for a remote audit? Does one need to have smart meters on all the buildings involved?
So there are some buildings that have interval data that's collected by the utilities that don't have smart meters. They are just automatically on a utilities interval metering system. But for buildings that are not on that system, then yes, they do need smart meters. Basically what we need to make sure we have is 12 months worth of electricity data that's coming through in interval format, so 15, 30, or 60-minute intervals.
Thank you. And in your ESTCP report, your results show a cost for the remote audit of about $3,000 per building. Is this the cost that FirstFuel charges for their service, or are there additional costs involved?
Since this project, we have moved to a different way of deploying our software tools, and it's a license-based cost. So it depends on the scope of the project, but it's no longer a building per audit cost.
Great. Can you provide some details for those that are on the phone and are interested in pursuing this?
They can reach out to me. I think my contact information is on the last page. And we can have a discussion around the scope of the project.
Wonderful. Thank you so much, Cara. And at this point, I'd like to pull Mike in and go through a couple more questions that we've received before we wrap up. So a question for you, Mike, and Cara, when Mike is done, please feel free to weigh in. In your opinion, what are the greatest future opportunities in energy efficiency for the Department of Defense? Or what are the new and exciting opportunities that you see on the horizon based on the work that you've performed thus far?
That's a big question, Rula. If I had to pick one, I'd say big data, funneling all of this data that's being collected from various systems, like distributed generation, microgrids, metering data, HVAC data, into the cloud, and that gives an opportunity to do some really new things, very similar to what FirstFuel has done with meter data, but on a much bigger scale. And I think a lot of energy efficiency opportunities could come from that.
Thank you, Mike. Cara, would you like to provide an opinion on this question?
Sure. So as I think Mike just alluded to, as big data gets even bigger and monitoring tools and other performance monitoring systems become more sophisticated, it's becoming easier to identify savings opportunities and achieve those savings opportunities faster.
Wonderful. Thank you both. Another question for both of you, and we'll start with you, Mike. What are the next steps for broader distribution of each of the technologies that you presented today? Mike?
Our next step clearly is licensing to large manufacturers, implementation of the technology into package units that we're able to do with our local partners is relatively small scale compared to the tens of thousands of air conditioners that are manufactured and installed every year. So our next step is, and is what we're focusing on for technology transfer, is partnering with major manufacturers that can produce tens of thousands of air conditioners a year.
Thank you. Cara, would you like to add anything?
So next step is kind of, since we wrapped up this project in late 2014 or early 2015, is that we're continuing on the path that we've been on, and we're working with over 30 customers, including the General Service Administration and some of the Department of Defense buildings. And we continue to expand our scope with adding on additional utilities throughout the U.S. and Europe.
Thank you. And since we have you on the line, why don't you please respond to this next question, and Mike will weigh in. As energy efficiency tools and implementations become more sophisticated, how are customers, and specifically Department of Defense customers, how are they benefiting?
So specifically, our government customers, Department of Defense and General Services Administration, have been benefiting from being able to use their data to identify opportunities quicker and reduce the amount of time that it takes to implement projects and act on those projects. So when these energy efficiency tools come out to the market and the Department of Defense starts using them, they're pretty immediately able to reduce their energy bills and their overall energy usage. And that's a really important factor for meeting those net zero goals that a lot of these bases have.
Thank you, Cara. Mike, would you like to weigh in?
Yeah, sure, Rula, thanks. I think the key benefit for equipment retrofits in general really is cost. With DoD facilities management and energy management budgets being very tight, it really comes down to getting the most improvement in energy efficiency for the least cost. And I think technologies like ClimateStat and others are able to offer a bigger gain in efficiency per dollar, and that's where the DoD customers are benefiting most.
Thank you so much. And then one last question for both of you, starting with Mike. Utilization requires crossing boundaries between energy management, facilities management, and procurement. Do you have any recommendation on how this crossing boundaries issue should be approached?
That's a question I was hoping someone else would answer, Rula. Thanks. That's a difficult issue, especially with our DoD customers, is that implementing new technology, advanced technologies, often requires groups on the base to work closely together that don't usually work together. So our approach has been to communication, really, is trying to get everybody together at the table and really talk about what we're trying to do and why, and try to come up with a solution that meets everyone's requirements.
Thank you. Cara, would you like to add anything?
I think Mike said it well, where it's really important to get everyone around the table to get buy-in for each of the teams, the energy management teams, the facility management teams, and the procurement teams, to really understand why we're doing what we're doing, get that buy-in, and then have them involved throughout the project to ensure its success.
Thank you both very much for very interesting presentations. Mike, do I hear you wanting to add in something?
Yeah, I just wanted to add one more thought on that. If anyone listening has any suggestions or advice on how to get these groups to work together, I'm sure Cara and I would both appreciate it, and so would everyone else. The key issue that I see is that one group may be benefiting from it. For example, the energy management group is getting the benefit of the energy savings, yet maybe the facility management group is the one that's having to pay for the upgrades. And then the procurement group, I'm not really sure what benefit it is to them. So it's difficult, and we're definitely open to anyone that would like to share a success story.
Thank you. All right. Well, again, we'd like to thank our speakers and remind everyone that our next webinar is on Thursday, January 26th, in 2 weeks, and it will be on award-winning CERTUP and ESTCP projects related to weapons systems and platforms. The webinar will feature two speakers, Mr. Gregory Kirshenstein from the Office of the Secretary of Defense for Maintenance, and Mr. Stephen Gados from the Boeing Company. Registration is already open for this webinar, so please visit the CERTUP and ESTCP webinar webpage to register for this and other future events. Before we conclude, I would like to remind you that both the audio and a copy of the presentation of today's session will be archived on our webinar webpage in case you would like to refer to them in the future. We would appreciate it at this time if you can please take a moment to complete the survey that will pop up on your screen. This concludes today's webcast. Thank you for your time.